Welcome back, everybody. Have you guys had lunch already? Okay, quick lunch, right? It was only half an hour. Thank you very much for being here and for taking such a short lunch. I wouldn't do that, okay, but I have to be here. It's my session. I would like to ask you for the first question, which is why are you here? Why do you want to be here? Why this session? Why machine learning? Okay.
It's a buzzword.
It's a buzzword? Okay, that's a good one. Anyone else? Just curious? Yeah. It is a hot topic, yes. Okay, here's the thing. Machine learning is a hot topic, but most people think that machine learning is just for data scientists, right? It's a new thing to have data scientists where you need to learn a lot of statistics, you know, a lot about handling information and all that. It is not. So the question is, how many of you guys are developers? Hands up. Okay. How many of you guys are DBAs? A bit more, hopefully. Okay. How many of you guys are lawyers? Any lawyers? No, hopefully not. Seriously? Oh, come on. I had a joke about lawyers. No, I can't say it. Oh. Okay, so any data scientists? I know there's one. Two? Okay. Okay, three. Okay. So you guys that didn't raise your hands, what are you guys? What do you do? You know, IT pro, you know, administration stuff, maybe? Okay, so that works. I forgot about managers. I thought about lawyers, I forgot about managers. More managers? Okay, one more. Okay, so here's the thing. You have this session, which is a nice beginner session, and I hope you guys take a look at it, and after this, you are able to try it for yourselves, okay? There really isn't any difficulty in doing this. I'm going to make this the very easy way, no math, no complicated stuff, even no codes, for you to guys just drag and drop some boxes and make it really easy for you guys to have no excuses to try this at home, okay? You really should try this at home because it's very easy. And afterwards, there is a session by Manny about SQL Server and R. It's not in this room, it's in another room, but if you are interested in this, then this is kind of a beginner thing. That's a continuation of that, so you should really try that session afterwards, okay? So, what can we say about machine learning? Oh, first of all, we should thank all, you know, all the sponsors and all that, because, you know, this is the first time we have a SQL Saturday here in the Czech Republic, right? Okay, so yeah, without all these sponsors, it is really difficult for you guys to get this for free and all the food and everything, so thank you very much. Okay, so who am I? You have my contacts there. I'm just a crazy guy who does, you know, crazy stuff like IoT and, you know, go to places just to get food. That's really the reason I come to these places, because they give us food. And if you want to contact me, there are my contacts in my websites. It is a very small website, but at least it has my contacts, and they're like duplicate there as well. So, okay, so I have someone. Oh, thank you. I forgot to turn off the notification thing. Sorry about that. Yeah, it's being recorded as well. Oh, amazing. Thanks, guys. Okay, so one of the things people usually confuse about is what is the difference between machine learning and artificial intelligence. So most of you already seen from films and all that, oh, artificial intelligence is going to take over the world and all that. Yeah, it doesn't really work like that, right? Because someone else has to do the development part to make sure that the computer knows what to do, how to take over the world, right? You need a bad guy to do that. So one of the things that you can actually do with artificial intelligence is to try to do some, maybe think of this as a developer's point of view. You do some sort of code that is adaptable, so it is intelligent to figure out how to solve problems in the future, even if you don't predict them, okay? So that's the general concept of artificial intelligence. Obviously, we're not as intelligent as Skynet or anything like that yet, okay? Although we do have Cortana and, you know, all the competition for Cortana, but we're still not at that level, although we might be closer than we think. Okay, so machine learning is something a bit different with a different usage. With machine learning, first of all, machine learning is not a different thing than artificial intelligence. Machine learning is actually a subset of artificial intelligence. So what you get with machine learning is, So one of the things you can actually do is, with machine learning, is try to get the computer to do all the work for you based on very simple algorithms in most cases, to try to figure out stuff like pattern recognition, figure out a lot of trends with all the information, right? And what's the objective of that in the end? You know, try to predict stuff, right? So you want to predict stuff like, okay, does he have a good credit risk? Is that person likely to die, you know, in a year or something like that? Will the plane crash? And this is kind of a true-false thing, but you can actually say stuff like, okay, I want to predict how much, there is an example for that actually, how much a car costs based on its characteristics, right? You can actually do that. Okay, so this is a crazy map because I know most people like maps, okay? So I'm not going to point with a laser thingy because it doesn't show up on camera, but I can actually do it with the mouse. So most DBAs probably go around this area, right? And if you go on more to the BI kind of thing, then you're maybe in this area. If you are a statistics guy or girl, you probably know this area very well, but artificial intelligence, artificial intelligence is somewhere around here, right? And machine learning is just a subset of it. Okay, so we have a lot of algorithms. I'm not going to get into the boring stuff, okay? We're just going to talk about one or two which are maybe the most common. So one of the things we have is linear regression. So you guys heard about this from school, right? Everybody's seen this. Oh, let's draw some points on a chart and then just try to draw a line which is as close as possible to those points, right? I don't want to get into mathematical precision on the definition of this, but okay, you can actually do a lot of stuff with this information in terms of, you know, medicine, biology, and you know, economics as well. You know, that's crazy thing that screws up all of our lives. Okay, but afterwards we have another algorithm, and this one seems a bit more complicated, but in fact conceptually it's actually much simpler. So we have logistic regression, which basically means that and in this case in particular, the example here is a two-class model. Imagine this. Okay, so it does say African and European small, African big, okay. I promise you I didn't make this on purpose. It was the first slide I got off the internet, so if you have any you know, funny questions about sizes and African people, trust me, it's not the reason I wanted to do this, okay? Seriously, I got that comment before. So one of the things that you can have here, imagine this blue one here is, for instance, you try to do an exam. And you either have basically one or two options, right? You either pass or you fail, right? So just forget about the numbers here, but imagine that the line here is something like, oh, I studied 1 day, 2 days, 4 days for the exam. The more you study for the exam, the more likely you are to pass the exam, right? So if you move on to the right, you're probably more likely to be on that top set of balls things there. But if you go to the exam and you don't learn anything, you don't study anything, then you're most likely to fail. It's not always perfect, obviously, because you know, you might not study anything and still pass. You know, you have those anomalies there as well. But in trending cases, that's what's going to happen, right? So if this was a really perfect system, that line over there would be just as vertical as that green part over there, which is up to a certain point, it would be all the low part up to a certain point, it'd be all the higher parts. And this is called a two-class model. There is a reason for that. And this can be anything. This can be a true, false. This can be a yes, no. This can be a yes, it's going to happen. No, it's not going to happen. This can have a lot of significance. Or this can simply be, depending on the type of information that you decide to use, this can actually be just a random decision on a threshold that you decide. For instance, I'm going to show you a simple example, which is on Azure, where they decide that they want to figure out if people earn more or less than 50,000 gold coins. Okay, so they decided on that threshold. Okay, so it's a true false thing as well. So it's less than this or more than that. So it's still two options. Okay, but still you can much easily detect one of these. Still, one of the things that happens here is to detect if it's true false. In this case, one of the things you do is you try to figure out a number which let's think of it as a percentage, right? Or from 0 to 1 or something like that. And the closest you get to 0, it's more likely to be a no or a low value or whatever you want to call it. And the more likely you come to the 1 or the 100%, it's more likely to be in the yes section, so to speak. So, okay, I'm going to show you that in a minute with a slide. Just going to go over the slides for a minute and then just show you all in a demo. Okay, so does anyone remember decision trees? Okay, so you guys know about this. Okay, I will give you a very simple example. This is how I learned this, 15 years ago, and it is still valid. So imagine you're thinking of an animal. This can be maybe a cat. Okay, so this is a decision tree where you classify all types of possible animals. So imagine the computer is going to say something like, okay, you want me to guess the animal, but you have to say some characteristic about the animal. So me as a computer, I'm going to ask you, the person, what the characteristics of the animal are, and then the computer will try to figure that out and tell you. So the computer might ask something like, is it a mammal? So is it an animal, not a fish or anything like that? Is it a mammal? So yes, a cat would be a mammal, so we would go somewhere here. Second question would be, is it typically a pet? And you would say yes. And then the computer would say, oh, with all the information that I have, I know that the animal is a hamster. And clearly it isn't, right? Because there is no hamster. It is a cat. So when you get to that point, what happens is the computer says, okay, it is not the animal I expected. I have to do something about it. So I ask the person, what is the characteristic that separates a hamster from a cat? And you can say something like, okay, it has, it has fangs on their teeth or something like that, right? You can actually say something like that. And the next time someone asks, he's going to say, oh, wait, okay, do people use it as a pet? Yes. And then he asks another question, does it have fangs? If it says yes, then he suggests that's a cat. If not, then he suggests that might be a hamster or not. Okay, so we'll keep asking and learning. The computer will keep asking and learning about this. This is a very simple, binary tree, very simple to do. Although the real models are quite more complicated sometimes. Okay, so I want you guys to get the general idea how simple this can be, but you know that in the background something much more complicated might be happening. Okay. And then imagine you want to classify a dog. So it's all the same up to here, right? It's commonly known as a pet. Then yes, it has fangs as well. But then what's the difference between a cat and a dog, right? So then you decide for yourselves, because it's an ongoing discussion. They all look the same. They all have 4 legs and all that. But there might be some characteristic that separates them, like dogs drool a lot, maybe. Okay, and then the computer will learn about the difference between a cat and a dog, and it will add that to the tree. Okay, so I'm not sure if you know about this. Does anyone know about this website? This is really old stuff. It's like 20 years old or something. It's a really funny website. Okay, we'll probably not have a lot of time to look at it, but I just wanted you guys to know that memorize this address. and just go to the website, and then it will ask you a series of questions, and afterwards you will try you will try to figure out what it is. So 20 years ago, when that website didn't know a lot, you just ask the question, it is an animal, you chose a cat, a dog, something like that. You'd probably guess that in about 7 or 8 questions. Nowadays it has so much information accumulated over 20 years that 20 questions, like the original name of the website, 20 questions are not enough to answer everything. So now they kind of give up on the 27th question. Okay, but 27 questions is still a lot, but then he actually gives up. But in most cases, he figures it out. So just to give you an example, before we were thinking about this yes or no, so this is kind of a binary thing, right? And you still have the yes or no, but think of this as something like 100%, and then the unknown is something like, okay, I will not go here, I do not know the information. Something like irrelevant, you would say, okay, this branch of the tree does not make sense to be in because this is not relevant for the classification. And be careful because you're thinking of this as a simple binary tree, but in fact it can be a very complicated tree because it has multiple types of classification, like color, size, and everything. Everything should be a different kind of, let's call it, dimension. Okay, but then you have something like sometimes, maybe, probably, doubtful, usually, depends. So you can actually assume that that can be something like, yes, it's 100%, no, it's 0% probability, but the other ones are something in the percentage, Maybe it's maybe 50%, probably it's in the line of maybe 80%, doubtful, maybe 10, 20%, okay? So he actually takes that information, he's able to calculate all that and try to guess the information. He's not always right, the algorithm for this website in particular is not perfect, but you get the general idea how he is able to do that, okay? So, but when we're talking about Azure Machine Learning, you don't have to know exactly how he implements that, okay? It's not your problem. Think about this, you want to implement a simple, very simple solution. You just want to get the information there, just drag some boxes and make sure that you get the best information possible for that. And I'm going to get into that in a second. Okay, one of the other algorithms that you get is the clustering algorithms. So one of the things you can do is to try to find things that resembled, things that are resembling themselves. So you can actually find stuff like go to social networks and try to figure out, these people are, they have the same characteristics, right? They like the same things and all that. So you can actually use that to give them suggestions about products or something like that, because you classify them as people who like cats, okay? So if they like cats, they probably like advertisement about cats, maybe cat clothes, which is terrible, right? Okay, but something like that. And if you are a dog person, then you're probably not in the same group as a cat person because, they kill each other, right? I have that experience. So you're probably somewhere else, but still you get advertising for something else. But obviously you can get a lot of interesting information, not from gathering people, but from looking at the ones that are outside the circles, right? So imagine this, all these that are outside the circles are probably going to be either an exception or an anomaly, okay? So if they are an anomaly, maybe, some people trying to hack your server or something like that, then that is something you want to look at because that is very far from the center of the cluster. So you might want to take a look at that. And that can be done in an automatic way, or you can actually get notified of that information and say, okay, just take a look at that. That might be suspicious. Just have someone, a person, take a look at that. So that actually depends on the area of business you're in. Okay, so how do you decide which one of these algorithms is correct? Okay, and I promise you, these are the 2 last slides, okay? Then I will do the demo stuff. There are 2 slides, I'm going to show you the 2, okay? So this one and this one. This one is the oldest one, this is the old version, but still this old version explains things a bit better than the new version, okay? So these are available in the slides, you will have this available in the slides if you download it afterwards. And these are some sort of cheat sheets for you to be able to figure out what kind of algorithms you want. So when you start here, so imagine you have a problem. So the problem is, oh, I want to figure out, if people like the same kind of things or something like that, then yes, you go immediately to clustering, and you're done, and you have a few algorithms on clustering. Then you have to decide which one, but I'm going to get into that. Okay. Afterwards, if you don't want that, you want to predict stuff for the future, you want to know what's going to happen in the future, then you basically have one or two choices. You either want to predict values, which is numbers from 1 to 100 to 1,000 to whatever. Okay, you want to predict value. How much am I going to earn based on the market that's happening now? If I invest in this thing, how much money am I going to get in 5 years or something like that, based on past experience? So you probably want to do regression here, because the thing you're after is an exact number, right? It's a number in the middle of 1,000 possible combinations of numbers. So you want to try regression with that. And if you ask, which one of these should you select? So for me, the easiest thing to do, okay, I am not a data scientist. I don't want to be, okay? It's too much math for me. So one of the things that I usually do is, okay, typically I select one or two of these which I know have worked in the past. Okay, so past experience is also good to select an algorithm. But one of the things you can do is, if you're not sure which algorithm you're going to use from this or all this box here, then you just try them all at the same time. Okay, why not? It doesn't cost that much money. In most cases, it's zero. So just put them all there, try them all, and see which one works best. Okay. So that be careful, because this might work okay now, but in 6 months' time, when your information changes, that might not be the same thing. Okay, so sometime in the future, you need to retrain that model and look at it again and make sure it's still the best algorithm for the job. Okay, but still. Okay, so if you want to predict some sort of values, numeric values, integer values, or whatever, then yes, you want to do regression. Otherwise, if you want to predict categories, okay, stuff like male or female, stuff like, Czech, Portuguese, English, or something like that. You want to figure out the nationality, and that's well defined. That's not a a variable number. That's a well-defined set of possible choices. Then you want to try multi-class classification, or in the special case of two-class classification, which is the kind of true-false, yes-no thing. You have a lot of options here which are really optimized for two-class. Otherwise, you just use the multi-class approach, and one of them will work out okay. Then you have the other ones, which is the anomaly detection. So I should probably mention that if you want to detect anomalies, it's not just that. You have anomalies in all types of algorithms, okay? Clustering, multi-class, and all that. You will have many types of anomalies that you can find depending on exactly what you want. So it's not a specific kind of thing. Okay, there is the other slide is a bit different. It has kind of the same information, but shown in a different way. I think it is easier for you guys to understand the first part. At least it was for me, okay? So both of them are here for you to look at. Okay, so I'm gonna try to do a demo. Hopefully I have internet here, which is also a very difficult thing. So, do any of you guys have an Azure subscription? So that's the important question. Okay, not many people. But have you ever tried Azure, for the people who don't have a subscription? Okay, not that many people. So, one of the things I hate when I go to a presentation is I go there and people say, oh, you should try this, it's on Azure, it's really nice and it's okay, but yeah, but I don't have an Azure subscription. What the hell do I do now, right? It is boring. So you just stay here and say, oh, I spent an hour learning something I'm never going to use. No, you have no excuses, okay? So one of the things you can actually do is just go to azure.com, okay? And it takes a while, but yeah. So one of the things here is start for free. Just as simple as that. It's not very difficult. You start for free. I should say something, the camera is rolling, but I'll say it anyway. Okay, so you have a 1 month free trial, but after 1 month, there's nothing prohibiting you guys from trying a new free trial, okay? Just have to get a different email account. You know, I didn't say this, okay? I know it's being recorded. So there is another alternative, or maybe two alternatives, which is the Dev Cloud Essentials and the IT Pro Cloud Essentials, which are a pack which is free and it gives you access. I'm not exactly sure. One of them is like 25 euros over a period of 1 year, and the other one is like some 150 euros over a period of 3 months, I think. So either way, just try them all, okay? Because you can actually get them. And if you have an MSDN subscription, if your company has an MSDN subscription, then you get Azure for free. Okay, you just have to go to the MSDN thing and say, yes, I want the Azure benefits, and then you're done. Okay, you can actually use 150 euros per month just to have fun with it. Okay, so no more excuses not to use Azure, right? So just try it all, try the machine learning, try, you know, VMs, but be careful, okay? With machine learning, it is okay to use it, no problem. It doesn't spend that much money. If you are using the web services associated with the machine learning, that might cost you money, okay? So be careful with that. If you're not going to use them, just, delete them, because, okay, that's going to spend money for you. And, you know, with everything else, you know, virtual machines and all that, but do give it a try, because, you know, the machine you're looking at, the one with the reds, reds titles and all that, that's a virtual machine in Azure, okay? So my computer is really small, has 4 gigabytes RAM, and I wanted something big, so this is a machine that has 16 gigabytes on Azure. Just like that, okay? At the end of the session, I'm just gonna turn it off, and I'm gonna pay a few cents just for using it. But it's there. If I wanted 200 gigabytes, I would use it, okay? So, okay, so you start with Azure, and there is something, some of you probably already know, which is the Azure portal, which is a ugly looking, slow thing, okay? Yes, and I know I'm being recorded. It's on purpose that I'm saying this. So it is really slow. And imagine this virtual machine is actually on Azure, so he's talking directly to Azure, and still it is very slow. So this is my dashboard. You can actually pin a lot of tiles on the dashboard as if it was a normal, yeah, you can actually make funny stuff with it. Yeah, okay. So I'm just going to wait for it to finish loading. In the meantime, what are we doing? So we have to start a new machine learning workspace, and I'm going to show you exactly how you can do that. Okay, so hopefully this is going to be okay. Yeah, let's just start that. Okay. Okay, so this is the plus sign. Say I want a new object, okay? And the first object I'm going to say is, yeah, you can actually go to the categories and try to find it. Good luck with that, okay? Because every week they're going to change something there and you're never going to find it. Okay, trust me on this, it's terrible. So you just say machine learning, and they actually suggest 1 or 2 things, and the one you want is the machine learning workspace. So I'm just going to get into this. Now it's on intelligence plus analytics. In a month's time, it's going to be somewhere else, okay? Okay, so let's just create this. So creating this is going to take a few minutes, so I'm just going to not show you the steps how to create it, but I have one created already because it takes like 5 minutes, so I'm just going to avoid that. So just have a workspace name, just name it whatever you want, like SQL Saturday Prague, okay, something like that. You select the subscription you want to. Typically you only have 1 or 2. Then you have to select a resource group. So a resource group is something like a container where you put objects in, and if you're fed up with the objects themselves, you can actually take the container, delete it all, okay? So it's actually easy to get rid of a lot of objects that are related to each other, okay? For instance, the virtual machine has about 5 or 6 objects, like, you know, public IP, security stuff, groups and all that. So you just put it all in one resource group. If you don't want it, just trash it. Location, that's an important part, because obviously you don't want to be here in Europe and connect to a data center in China, right? It doesn't make any sense. So you want to connect probably to the closest one you have from here. Having said that, if you try, for instance, West Europe or North Europe, depending on the stuff that it is, you should really take a look at the pricing, because, for instance, North Europe is actually much cheaper than West Europe. Okay, Germany and England's data centers are actually expensive as well, so I'm not going to comment on that. And apparently, according to the guys in Azure, they're not in Europe.
Okay, if it is like, what is the difference? They have better services?
No, I would say they're kind of the same in most cases. I would say that some of them have more services than the other, because sometimes they deploy more stuff here and then more stuff here as they roll them out for the first time. But in terms of service itself, as long as both of them have the same kind of services, they're going to be provided the same way without any difference. Maybe your problem might be either the price, obviously, or maybe the distance to the data center. That's going to have some latency, and it's going to be bad for your business eventually. Okay. Okay. So you just select a location. Then you will need a storage account, because you will need to store all that information in a storage account. Basically, it's a place where you put the files and all that. And then you have to decide on the tier. So in this case, I only get the standard, which is okay. But then you have a web service plan pricing tier. So just to make this this clear, you don't have to pay, at least as long as it's less than an hour, you don't have to pay to train the models. It's free, okay? The stuff I'm going to show you, only the web service, only that you have to pay for it, unless it takes more than an hour or something like that. But in most cases, it takes like 5 or 10 minutes, so we're safe with that, okay? Okay, so the normal situation, I would recommend is just select this one that says Dev Test. It's free, and you don't have to pay for it, but you can only use it once in a subscription. So I have used it before in the one I'm going to show you, which is already created, so I can't use it. As you can see, the other ones are a bit more expensive, right? 10 times more, 10 times more, so they are a bit more expensive, but at the same time, they allow you to do 50,000 transactions, which is to ask the machine learning thing 50,000 times, 50 million in this case, times to protect stuff or to whatever, right? So it takes still a lot. Okay, so we just created. I actually pinned it to the dashboard to make it look good, and I will try to go to the dashboard and show you. Okay, so I have an ugly looking tile. And then I have basically 3 options coming up here. So if you go to the gallery, I'm not going to get a lot into the gallery, but the gallery is basically a place where you can share your algorithms, your experiments, and all that. You can actually go there and share that. And you can actually go and see a lot of algorithms that a lot of people have done and use them. So it is a good collaboration thing. The web service management, I'll show you that in a second. Just open it up to be there for us in a second. But basically, I'm going to launch the Machine Learning Studio. There are a lot of extra configurations on the left of it. I didn't get to talk to you about that, but basically, they're not very important at this beginner level, because most of the stuff you do to configure it are actually in this thing, which is called the Machine Learning Studio. Okay, so when you start up, I'm already signed in apparently, but they say something like, okay, log in down here before that thing. They actually say something like log in or sign up or something like that. I'm actually going to go into my workspace. Just by the way, in all this page you have a lot of resources, so you probably want to take a look at the resources as well, because some of them are actually videos. They're very simple to see. Some of them are actually more complicated text, so it is a good idea for you to take a look at them. So let me explain what we're seeing here. So let's start with the easiest one, which is the settings. So you go to the settings. Basically, you have obviously the name for the Machine Learning Studio. These authorization tokens are the ones that when you have a web service, you want to connect to the web service there, then you have to use one of these. You can actually change them, but in most cases you can just use the ones that are here, as long as no one films them, right? Okay, but yes, don't worry. I will turn off this workspace in the end. So I actually have one account here, which is the one that Azure creates for me automatically because it's my Azure account. But if you want to, you are allowed to invite more people to join you. And as an owner, you get full access. As a users, you only get access to to create some experiments and have some limited interaction with that. But in most cases, that's going to be enough still. Okay, so then you have all the information here. So a project is basically a container for a lot of experiments and web services and all that. The experiments themselves they have a weird name. Okay, so we're not scientists, so calling them experiments is a bit strange. But basically what we're going to do here is, this is going to be the drag and drop kind of thing, where you put all the information there, and then you're going to run that. It's going to train those models, and that's called an experiment. Okay. So then you have the web services. Those web services connect to those experiments and allow you to remotely connect to those experiments and try to get some values. I'm going to give you an example of that in a second. Notebooks are, they actually join a lot of information like documentation and all that put together, but not really relevant in terms of information now. And then you have the data sets. Okay, so a data sets, you have a lot of samples already. And I'm going to show you a sample which I have here, and we're probably going to talk about this. So one of the samples we're going to talk about is some adult demographics, something like that. And I'm going to give you the typical Azure example, which is you have all the information on the left, and you're going to try to predict that column on the right, which is to figure out if person earns a lot or doesn't earn a lot, right? So he's going to base that on if he works in a private sector or a public sector, or if he's self-employed, what's the kind of education he has, have no clue what this number is, what type of education again, and marital status, occupation, so the job he does, race, sex, capital gain, capital loss, number of hours per week that the person works, and then the country he's in. So basically, how do we do this? I'm going to do this the easy way, so I'm going to be lazy. And I'm just going to ask the guy to create a new experiment for me, okay? As in how do you say this? As in a wizard, okay? So, experiment. So, easy way to do it. Try the green stuff, and the green stuff actually has an automatic way to do stuff. I'm going to show you, but you will see I will not be touching the mouse. He's going to do all that for me, okay? It's not a video. It's actually him dragging and dropping all the stuff, but he's going to do that for me in a much faster way. So first off, he's going to create a new experiment. And in this case, it's actually a blank experiment. So what he's going to do is, first of all, he's going to obviously rename the experiment. That's obvious thing you should obviously do, and then you're gonna get all that data set that we've seen, the one with the demographics is gonna get all that into here. So he already has that data set downloaded into the samples. He's gonna get that into there. So simple enough. He's gonna confirm that we can actually see it because it's exactly the same thing. And here you can actually have an histogram of how the information is distributed, so that that visualization actually helps a lot when you look at this information. But then how do you do it? Okay, you want to train this to predict stuff. So you're going to take a percentage of this. In this case, it's 70%, and you want to do that for training, and then the remaining 30% are going to be there to test the model. Okay, to make sure that everything is correct and it works fine. So first off, he's going to split the information. Have you guys noticed this looks a lot like integration services, right? How many of you guys use integration services? A few of you, okay. But it looks a lot like integration services, right? If you're used to that, you've done that already. So one of the things he does is going to split all the information in two parts. The one here is going to get 70%. The two here is going to get the remaining 30%. And he's actually said he's going to randomize the rows he's going to supply. So it's not the first 70% and the remaining 30% as well, okay? So, then you're gonna select an algorithm. So, if you're trying to predict something that's less than 50,000 units and more than 50,000 units of money, then it's a yes-no kind of thing, right? Less or bigger, so it's a two-class thing. Agora, which one it is? Well, he's actually going to select one for us, which is the two-class boosted decision tree. But if you don't know which one it is, you can actually try every one of them and just put them all there, try them, and see which one has the best results. So one of the things that just showed up, he actually decided here that he wanted to predict the income column, which is the last column in the end, okay? I will show you that again in a second, but still, I want you to know about this. So one of the things he's going to do is, he gets the algorithm selected here, and then he's going to do this square here. You can't really see it, sorry, I can't really drop it during the wizard, but he's actually going to train the model with that information. Now he's going to try to make the predictions with the remaining 30%. And then he's going to get a box called score model. And he's going to take the remaining 30% from the splitter there, and he's going to try to predict there based on the other one he just connected to, which is the information from the training model. That's not actually a pipeline with the the records. That's actually a pipeline with the intelligence stuff that he learns while training the model. So it is a bit different than integration services, because all these aren't pipelines with always data. Sometimes it's just a connector. Okay, so it looks strange, but sometimes it's just like this. So he's going to take like maybe a few seconds to run, maybe a minute, and during this, what's going to happen is you're going to see something that's really close to integration services, which is these arrows here actually show up gradually. I think he already did this before, so it is quite fast for him. But in the end, he's going to predict, yeah, go. Okay, it takes a while. So as you can see, there are two new columns, and the first column is going to try to predict the information from the previous column, and in the last column there is a probability, from 0 to 1 or from 0 to 100%, wherever we want to think of it. And then he's going to try to analyze this with the evaluate model box. So basically you can get information about this, a histogram of all possible values. I'm going to show you that in a second, as soon as this closes. So one of the things here is you have the true positives, false positives, true negatives, have all the information. You can actually slide this thing from left to right to decide where the threshold is, and to make sure if you have too many false positives or too many false negatives or something like that, you might want to slide the threshold. For me, I would say if you want to do something that's actually risky, you don't use just that threshold. You actually take the absolute value from the percentage value and say from 0 to 20%, that's guaranteed. From 80% to 100%, that's guaranteed. Somewhere in the middle, I'm not sure. Okay, so I would not use this at face value all the time, right? Okay, so there is an option to set up a web service, and I'm just going to do that. So you can see this is just as simple as you can, right? Any one of you can just go here, press the green thing, which is the wizard, and just go there. Okay, so just as simple as that. So he actually gets web services input and outputs. So okay. So I will show you this, but then I will show you the web service running from a previous service that I already started. Otherwise, it's going to take a long time. So one of the things he's actually going to do here in the first one is actually trying to figure out which fields you want to take in to be sure that you try to predict the information. And those fields are actually these ones, right? So all the information from here to here is the information you want to feed to the web service for you to learn, right? And then the web service is going to return this to you somehow, okay? So he's going to figure out that for the input, he's going to want everything but the income column, and for the output, he's going to want nothing but the scored model and the probability, right? So he's going to say exclude. He's going to exclude income because he doesn't need the income. Sorry, this is taking a bit of time, guys, because this demo is actually a bit slow. Okay, the output schema as well. And after this, we're all done to deploy the web service. So notice here, in this down part here, there is a button to deploy the web service, and he actually suggests deploying the web service himself. But there is a problem, which I suspect has something to do with having the classic deployment and the Azure Resource Manager deployment. So I don't think that this wizard is ready for that. So when you click to deploy the web service, it doesn't simply work. Okay, so it is okay. You can actually stop the wizard here and then ask to deploy the web service by yourselves. Just press the button by yourselves. I'm not going to do this because it's going to crash. It's been crashing for like 3 or 4 months, so it's not going to be different than last night, right? Okay, so I'm going to go to web service management to show you what happens with the web services. So I actually have a web service. It says test 1, but basically it's the same web service as you got that, just with a different name. And you have a lot of information here. I'm actually using this thing which is called Plan NDML, which is on the dev test here. The one I told you was free. Okay, so he actually tells me how much I've been using. Since I've only created this last night, there isn't much information up to date. But maybe in 1-2 days he actually adjusts this information. Okay. So wait a minute. But I want web service test 1. Okay. So I'm here in the test 1 web service, and one of the things I can actually do is see the information about it, how much it's being used, etc. And when you go to the configure options, you have those keys that you can access the web service and a bit more information. These keys are going to be used in front, but if you want to consume it, this is an important part. Think about this. If you are developers, if you are DBA guys, then this is one of the easiest things you can actually do. So he's going to show you the primary key, secondary key, and all that, but you can actually get the web service and go into this addresses here and use them. And he actually has examples in C#, in Python, in R, and you can actually try them. Just copy paste them onto Visual Studio and try them out, and they work. But still, that is a lot of work because I'm a lazy guy. So you can actually press here, okay, and try this one in Excel. Okay, so I'm just going to do that. He's actually going to use the web service, the normal web service which is here, but he's going to consume it with Excel. Okay. So I'm not going to download it. I already have it in my machine, but still, okay. So this was the one. I downloaded this last night. Trust me, it's exactly the same. Okay, so one of the things you get is all this funny business, and you say, yes, I want to predict this information. So, if you want to do this, the easy way is just use sample data, and he actually fills some of the columns for you, but still that is not enough. You want to fill a bit more of the columns, so you actually decide to use this one. Okay, you select the ranges you want. Okay, I'm just going to reduce this a bit so you can actually see it. Okay, so I'm going to put the results somewhere here. So P1 maybe, right? Okay, so if I try to predict it, basically I get nothing so far because all this information is quite incomplete. But since I'm a lazy guy, I don't want to fill all this up because I'm really lazy, okay? So I'm just going to get the original information which I've shown you, and I'm going to get some, quite a few numbers here, maybe these. Okay, let's imagine this is your application, normal application, that's connecting to a web service, one per line, and saying, I have this information about the person, I want to know more, right? I want you to predict this or that. So he will actually return that web service to you. So I'm actually going to put it here. Okay, so this part here is the stuff that he actually wants to predict. He's not going to send this to the web service. It's not part of the web service because still it ends in the end, right? It's an N here, it's an N here. Yeah, it ends in the end. But when he tries to predict it, he actually gets this information. So he's okay with this one. This one is wrong. This one is okay. This one. all these are wrong, okay? It is okay to be wrong. It's really no problem. But you think about this, oh, okay, so this person earns more than 50,000. Oh, you want to make sure this is right. Maybe this person does not earn more than 50,000. Let's recalculate and see if this is any different. So it's 99% now. If you recalculate it, it's 5% now, okay? So one of the things, if you fiddle around with this particular example, you figure out that this column in particular is very determinant to the results. Stuff like being married or not apparently have no actual weight on it, or very little weight, but some columns like this capital gain column apparently work a lot. So basically you can have anyone, even if they're not a developer, just go to Excel and use the model themselves. Okay, so you can have just a normal user. Okay, just input the information. You make the Excel look good or something like that, and just input the information here. It's going to miraculously show it downstairs. Okay, so you can actually do that. Okay, so we have a few minutes more, and I'm going to show you a few more examples. Oh, wait a minute. Okay. Oh, wait, it's not this one. It's this one. Yeah. Oh, this one. Okay. So. You have a few more examples. I'm going to show you maybe. Okay, so wait a minute. I'll show you this one first. So you have stuff like, you know, all this. You can actually press here and open in Studio and just say run and have it run and see what really happens. I have some already defined because, you know, to run them, some of them take like 10 minutes or something like that. So I really don't want to do that. I'm just going to show you that. So one of the examples that you have is they said it took like 500 companies from Wikipedia, maybe famous companies, and they actually, wait a minute, I'm going to try to zoom this for you. Oh, where's the zoom button? Oh, okay. Okay, so you get the information here. So it's maybe 500 companies here. Data set, visualize. So you have, you know, Apple and you know, a lot of companies here, and information about the companies, basically text information about the companies. So one of the things this algorithm does with the clustering is try to figure out companies that resemble themselves in terms of something, right? So you base that information mainly on the text that you see there, which is descriptive of the company. So it does a lot of things, okay? So I'm not going to get into a lot of what he actually does, but I can tell you that he actually trains 2 different models, okay? Not sure exactly why, but in this case, but it's an example, and you can actually go here and maybe see. Wait, results. Oh, I have to download it. Oh, okay. That's boring, actually. Okay, so this isn't very helpful, but I can actually go to Excel and just see it decently. Okay, so he actually assigned it to 1 or maybe a few groups. In this case, I think it's only 0, 1, 1 groups, but in some other cases it actually shows in 3 or 4 groups, and he tries to group those companies together. The aggressiveness, let's call it aggressiveness, of how many groups you decide, you can actually parameterize that yourself. Okay, you can actually decide what you want. Okay, so you can actually do extra stuff with this. Oh, sorry. You can actually do extra stuff with this, like I'm just going to show you a few of the extra things you have here. So the same was as integration services. You actually have a lot of boxes as well. So you have boxes for manipulating all the information that goes around, just like the integration services. Data input and outputs, where you import and export data from web services or something like that. Okay, you can actually fetch the information from the internet, from some web service about the weather, about, you know, all the stock exchange information, something like that. You can actually get that from other models as well. You can get more data sets into the same one, but you can also do stuff which, let's see if I can find it. Okay, so you have all these models. There are a huge amount of models, obviously. And then you actually have stuff like, if you are a person that understands R or understands Python and want to use it for statistical purposes and actually develop the contents of these boxes, you can actually do that. So you just go to an R language and just create an R model or execute an R script, and as soon as you create it, you actually have a lot of information. These are the input ports and the output ports. They already created that for you to help you out. And then you just have to fill in the blanks in the middle, okay, with whatever kind of function you need to solve your problem. And you can actually do exactly the same with Python. So it is available for you as well. In Python, you actually have to choose the version, but still you have the same kind of idea. Okay, more stuff. Yeah, then you have obviously the web services, and you have a lot of this. So my suggestion after this session, because we're practically running out of time, my suggestion after the sessions, if you want to know more, this is just an introductory one. If you want to know more, please go to the next session by Mani. Actually has a SQL Server on R, so he's going to talk about R. Maybe you want to learn a bit more about how to work with R and eventually just develop stuff here for machine learning. But okay, for most cases that you have here, just kind of as a conclusion, for most cases that you have here, you can actually, if you don't know which model to use, okay, one of those groups that you saw me show, okay, then you have to select one of those groups, obviously. But inside those groups, if you don't know which algorithms to use, that is okay. Just try them all at the same time. One will work, one will be better than the other one, okay? So just try one of those. Okay, so, that is the session. Do you guys have any questions? Please tell me that's spelled correctly. Yeah. Okay.
I have a question. That thingy in Excel for calling Azure Web Services, is it built in or some plugin or?
Well, that is a good question. I didn't have to install anything, so I would assume it's already.
It's some new Excel.
No, I think that's out of the box already in 2013 and 2016. I assume that's out of the box. But basically, you don't have to do anything. You just have to download the Excel from the web page that I showed you, and he's there already. Okay, you can actually do that manually. Okay, but a lot of work. He actually does that for you. He has the web service all configured, all really nice. So it's much easier to just download it and reuse it than to do it manually. But, yeah. I would say that older versions of Office are probably not going to be able to use this. Okay, so, but 2013, yeah. Oh, there was? Oh, yes, okay. Yes, oh, you're right, yes, you're obviously right. There was, wait a minute. He's right, yes, he's right. So it was configure, consume. Yes, you are right. You are right. So it is possible, apparently, yes. But I would say you have to add some plugin. Not really sure which one it is, but you probably have to add some plugin to make it work. Out of the box, 2013 only, I would say. Okay, more questions, guys.
I was interested in your cheat sheet roadmap.
My what?
Cheat sheet roadmap for choosing a proper algorithm.
Oh, cheat sheet. Oh, cheat sheet. Yes.
How was it constructed? Was it constructed, let's say, on used algorithms in machine learning Azure environment?
I'm actually not sure because Microsoft, somewhere in Azure team actually developed that. So I'm really not sure. It wasn't me. That's really not me. That's someone in the Azure thing that actually created that cheat sheet. So I really have no clue. Okay, so we're a bit out of time. We have our next speaker here already. So please have some comments for the session, okay? If you slept well, if you didn't sleep well, please show us some comments about that. Maybe sometime, next time I'll give you some pillows or something to sleep in, okay? Okay, well, thank you very much, everyone. Okay, thank you. Thank you, guys.